Okay, guys, we're going to get into the question and answer portion of the science passage with the table. Okay, I'll read the question and I'll give the answer and explain that as best I can. And away we go. Okay, this will be question number 22. The author uses the word backbone in lines 3 and 39 to indicate that. Okay, for number 22, we go with answer B, that the main structure of a chain in the DNA molecule is composed of repeating units. Okay, so once we go to number 22, we're going to go B there. Okay, we're going to go B. All right. It says there that it's a very long chain. It's a backbone, which consists of a regular alternation of sugar and phosphate groups. So we hear that backbone of DNA mentioned there multiple times. Okay, number 23. A student claims that nitrogenous bases pair randomly with one another. Which of the following statements in the passage contradicts the student's claim? Okay, contradicts means go against. Okay, so for number 23, we're going to go choice D. All right. The author explains that hydrogen bonds join together pairs of nitrogenous bases, and that these bases have a specific structure that leads to the pairing. One member of the pair must be a purine and the other a pyrimidine in order to bridge the gap between the two chains. Okay. Number 24. In the second paragraph, lines 12 through 19, what do the authors claim to be a feature of biological interest? Okay, so for number 24, we're going to go with choice D, DNA consisting of two chains. Okay, it says on lines 12 through 14, the first feature of our structure, which is of a biological interest, is that it consists not of one chain, but of two. Okay, they say that right in those lines there. Okay. All right, number 25. The author's main purpose of including the information about X-ray evidence and density, all right, is to choice C, provide support for the author's claim about the number of chains in a molecule of DNA. Okay. In these lines, the author claims that it has often been assumed there would only be one. The authors support this claim with evidence compiled from an X-ray. The density, taken with the X-ray evidence, suggests very strongly that there are two chains. That's what the X-ray proves to them. Okay. Number 26. Based on this passage, the author's statement, if a pair consisted of two purines, for example, there would not be room for it. Lines 29 through 30 implies that a pair B of purines would be larger than a pair consisting of a purine and a pyrimidine. All right. It says here that the pairs must contain both the purine and the other pyrimidine in order to bridge the gap between the two chains. Okay, explains that those are two chains that are connected through those two things, the purine and the pyrimidine. All right, number 27. The author's use of the words exact, specific, and complement in lines 47 through 49, the final paragraph, functions mainly to choice D. Emphasize how one chain of DNA may serve as a template to be copied during DNA replication. Okay, it says if the molecules contain a precise sequence of bases that the author can use in order of the bases of one chain to determine the order of bases to the other. If the actual order of the bases on one of the pairs is given, one could write down the exact order of the bases, almost like a duplicate for replication. Okay, let's go to question 28. Based on the table and the passage, which choice gives you the correct percentages of the purines in yeast DNA? Okay, and that would be choice C, 18.7 and 31.3. Okay, now lines 6 and 7 state that two of the possible bases, adenine and guanine, are purines. And on the table, the percentages of adenine and guanine in yeast DNA are listed as 31.3 and 18.7, okay, respectively. Okay. Number 29. Do the data in the table support the author's proposed pairings of bases in the DNA? I'm going to go with choice A, yes. Because for each given organism, the percentage of adenine is closer to the percentage of thymine, and the percentage of guanine is close to the percentages of cytosine. Okay, so by looking at those numbers, you can see how they kind of match up there. All right. The author says he believes that the bases will be present almost entirely in their most probable forms. This is true. The conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are adenine with thymine and guanine with cytosine. Sorry. Okay. Number 30. According to the table, which of the following pairs of base percentages in sea urchin DNA provides evidence in support of the answer to the previous question? Okay, for this one, we're going to go with choice A, 17.3 to 17.7, because it gives the percentage of cytosine in the sea urchin DNA and the percentage of guanine, 17.7, in sea urchin DNA. Its almost similar pairing supports the author's proposal. The possible pairings of nitrogenous bases are adenine with thymine and guanine with cytosine. And number 31, based on the table, the percentage of adenine in each organism's DNA, the same or does it vary, in which statement made by the author is the most consistent with the data. Okay, for number 31, we're going to go with choice D. It varies, okay, in the passage here. All right. The table clearly shows that the percentage of adenine in each organism's DNA is different, ranging from 24.7 in E. coli to 33.2 in the octopus. That much variability would exist, as predicted in lines 41 to 43, which states, in a long molecule, many different permutations are possible. So that was a challenging one, guys. A lot of science in there. You got to go back and keep reading the questions, going back to the lines that they're asking you to kind of go back to. It's kind of connect the dots as best you can using that chart. Thank you for your attention today, and enjoy the rest of your week.